Imagine a river so powerful that every year it could destroy entire villages, fields, homes, roads, everything standing in its path. But imagine if instead of destroying lives, that same river could power millions of homes, feed millions of people, and become one of the greatest engineering achievements in human history. This is the story of Tarbela Dam, one of the world's largest earth-filled dams built across the mighty Indus River, a project so enormous that thousands of engineers worked for years to make it possible, moving hundreds of millions of tons of earth and rock. Without Tarbela, modern Pakistan would look completely different. Its cities, its farms, its industries perhaps would never have grown the way they did. But here's the mystery. Why was such a massive dam even necessary? What problem was so dangerous that an entire nation decided to build one of the biggest dams on Earth? To understand that, we have to travel back to a time when the Indus River was both a blessing and a curse. For thousands of years, the Indus River has been the lifeline of this region. Ancient civilizations rose beside it. Farmers depended on it. Cities flourished because of it. But every year, the river behaved differently. Sometimes there wasn't enough water, fields dried, crops failed, people struggled. Then, without warning, massive floods arrived, destroying everything. A path, entire villages would disappear, thousands of families would lose everything. The same river that gave life could also take it away. Engineers knew something had to change, but controlling one of Asia's greatest rivers would not be easy. Then, another event changed everything. In 1960, Pakistan and India signed the Indus Waters Treaty. The agreement changed how river water would be shared between the two countries. Pakistan now needed a reliable way to store its own water, not just for today but for generations to come. That meant building something extraordinary, not just another dam, but one of the largest engineering projects ever attempted. Experts searched for the perfect location. They needed a place where the mountains were strong, where the valley was narrow, and where the mighty Indus River could be controlled. Eventually, they found it near a small town called Tarbela, surrounded by mountains crossed by the powerful Indus River. The location looked perfect, but building there would become one of the greatest engineering challenges the world had ever seen. Because this wasn't a concrete dam, it would become the largest earth-filled dam on Earth, and nobody had ever attempted something. In 1968, construction finally began. What engineers faced was unlike anything they had experienced before. First, they had to do the impossible: stop one of the most powerful rivers in Asia. You cannot simply build a dam in the middle of a flowing river. The water must be diverted. Only then can construction begin. So engineers designed massive diversion tunnels, not one, not two, but huge tunnels carved through solid mountains, each one large enough for enormous volumes of water to pass through safely. Imagine standing inside one of those tunnels. It feels less like a tunnel and more a giant underground highway built for a river. Once the tunnels were completed, the Indus River was redirected. For the first time in centuries, the original riverbed began to dry. Only then could workers start building the foundation of the dam. But another challenge appeared. The ground had to support an unimaginable weight. If the foundation failed, everything would collapse. Engineers spent months removing weak materials, strengthening the base, testing every section again and again. Only after they were completely satisfied did construction move forward. Then came the biggest task of them all, building the dam itself. Unlike the Hoover Dam, which is made of concrete, Tarbela would be built mostly from earth, rock, gravel, and clay. Many people still ask, how can a mountain of dirt hold back an entire lake? The answer lies in engineering. The center of the dam contains a waterproof clay core. This core acts like a giant seal, stopping water from passing through. Around that core, engineers placed millions of tons of carefully selected rock and compacted earth, layer after layer, truck after truck, bulldozer after bulldozer. Every single layer compressed until it became strong enough to support the enormous pressure of the reservoir. Nothing was left to chance. Every load was inspected, every section measured, every inch tested day after day, month after month, year after year. Thousands of workers worked in freezing winters and scorching summers. Heavy machinery never stopped. Dust filled the air. Explosions echoed through the mountains. The project began to resemble a small city. Engineers, surveyors, geologists, machine operators, truck drivers, welders, electricians, thousands of people working together for one purpose: to build something the world had never seen before. Then, after years of relentless work, the enormous wall slowly began to rise higher and higher, stretching across the Indus River. Visible from kilometers away, people watching from nearby villages could hardly believe its size. The numbers were almost unbelievable. The dam would eventually stand more than 140 meters high and nearly 3 kilometers long, so large that from one end the other almost disappears into the distance. Behind it, a massive reservoir started forming. Water slowly filled the valley, covering hills, old roads, entire settlements. The landscape changed forever, but while the world watched the giant reservoir continue to grow, few realized the hardest challenges were still yet to come, because controlling water is one thing, generating electricity for millions is something. Building a giant wall across the river was only half the challenge, because a dam is not useful if it simply stops the water. It must also control it safely every single day. Engineers knew the Indus River could never be completely stopped, especially during the summer when snow melts rapidly in the Himalayas. Millions of liters rush downstream every second. If that water has nowhere to go, even the strongest dam can be in danger. So engineers designed one of the most advanced water control systems of its time. Deep inside the mountain, they built massive tunnels. These were not ordinary tunnels. Each one was large enough to carry an enormous volume of water. The tunnels were lined with reinforced concrete built to withstand extreme pressure. Imagine standing beside one of these tunnels. As the gates open, a roaring wall of water rushes past with unbelievable force. The sound can be heard from far away. It is like standing beside a jet engine, but all of that energy has a purpose. Instead of allowing the river's power to go to waste, engineers decided to capture it. This is where hydroelectric power comes in. The idea is surprisingly simple. Water stored high behind the dam contains potential energy. When released, it rushes downward at tremendous speed. That fast-moving water spins gigantic turbines. Each turbine weighs hundreds of tons. As the turbines rotate, massive generators convert mechanical energy into electricity. No smoke, no coal, no oil, just the natural force of falling water. Day and night, hour after hour, the turbines continue spinning, sending electricity across Pakistan, powering homes, factories, hospitals, schools, entire cities. Today, millions of people depend on the electricity produced by Tarbela Dam, but electricity was never the only goal. The reservoir created behind the dam became one of the largest artificial lakes in the world. It stores an incredible amount of freshwater water that can be released whenever needed, especially during dry seasons. Canals carry this water across hundreds of kilometers, feeding some of the most productive agricultural land in Pakistan. Fields of wheat, rice, sugarcane, cotton, vegetables, and orchards, all benefiting from water stored months earlier. Without that supply, millions of acres would struggle to survive. In many ways, Tarbela doesn't just generate electricity, it grows food, it supports entire communities, it keeps industries running, and helps protect against devastating floods. When heavy rains or rapid snowmelt cause the river to rise, the reservoir absorbs a large portion of the excess water, reducing the danger for towns and villages downstream. It is like giving the river a giant safety valve. But despite its incredible success, nature never stops testing human engineering, because every year the mighty Indus brings something else besides water, something that slowly threatens the future of the dam. It is called sediment, and it has become one of the greatest challenges engineers face. When people look at Tarbela Dam, they see a giant wall, a massive lake, and powerful turbines, but engineers see something else, a silent enemy working every single day, an enemy that cannot be arrested, cannot be destroyed, and never stops coming. It is called sediment. Every year, the mighty Indus River carries millions of tons of sand, mud, gravel, and tiny rock particles. These materials have traveled hundreds of kilometers, carried from the Himalayas by fast-moving water. For thousands of years, the river simply carried them to the sea, but after the construction of Tarbela Dam, everything changed. The fast-flowing river suddenly slowed down, and when water slows, it drops what it carries slowly. Year after year, sediment began settling at the bottom of the reservoir. At first, it seemed like a small problem, but engineers knew the danger. Every layer of mud reduced the amount of water the reservoir could store. Little by little, the lake was becoming shallower. Imagine filling a giant bucket with sand. Eventually, there is less room for water. The same thing was happening inside Tarbela. This wasn't a problem for 1 year or 10 years. It was a challenge for generations. Engineers started monitoring the reservoir, constantly using survey boats, satellite imagery, advanced mapping systems, and underwater measurements. Every few years, they compare the lake bed, looking for changes almost invisible to the human eye, because even a small increase in sediment can affect the future of the dam. But sediment wasn't the only challenge. The enormous pressure of billions of tons of water never disappears. 24 hours a day, 7 days a week, the dam is constantly pushing back against nature. Tiny sensors hidden deep inside the structure measure movement, pressure, temperature, water seepage, and vibrations every second. If anything changes unexpectedly, engineers know immediately. The dam is watched every hour of every day, not because it is weak, but because great engineering requires constant attention. Over the years, technology improved. Engineers realized Tarbela could do even more. Instead of replacing the original dam, they upgraded it. New tunnels were modified, more powerful turbines were installed, existing equipment was modernized. Each upgrade increased the amount of electricity the dam could produce without building an entirely new structure. It was like giving a 50-year-old giant a brand new heart. Today, Tarbela produces far more electricity than its original designers ever imagined, and even now new expansion projects continue to increase its capacity. But perhaps the most remarkable thing about Tarbela isn't its size or its power, it's the fact that thousands of people still work every single day to keep this engineering giant alive, because building a megastructure is only the beginning. Keeping it safe for decades is the real challenge, and that may be the greatest engineering achievement of them all. Today, when millions of people wake up, turn on a light, start a factory, or switch on an air conditioner, few ever think about where that electricity comes from. Hidden among the mountains, the giant turbines inside Tarbela never stop turning day after day, year after year, generating clean electricity without burning coal, oil, or natural gas. This makes Tarbela one of the most important sources of renewable energy in Pakistan. Every second, thousands of liters of water rush through its turbines, each drop giving away a tiny amount of its energy. Together, those drops produce enough power to supply millions of homes. But electricity is only part of Tarbela's story. The water stored behind the dam travels far beyond the reservoir. An enormous network of canals carries it across the country, flowing through cities, villages, and farmland, bringing life to places that would otherwise remain dry. Without this system, many crops would never grow. Fields of wheat, rice, sugarcane, cotton, and vegetables depend on water released from Tarbela. For countless farmers, the dam is not just concrete, earth, and machinery. It is their livelihood, their harvest, their future. The project also transformed the surrounding region. Roads were built, bridges connected remote areas, entire communities changed forever. Thousands of engineers, technicians, operators, and maintenance teams have dedicated their careers to keeping this engineering giant running safely, but even the strongest dam cannot last forever. Without care, every machine needs maintenance, every tunnel needs inspection, every turbine must eventually be repaired or replaced. Inside Tarbela, teams of specialists work year-round. Some inspect massive steel gates, others monitor electrical systems, divers examine underwater structures. Engineers analyze thousands of readings every single day, because one small problem ignored today could become a major challenge tomorrow. This is what makes modern engineering so remarkable. Building something enormous is only the beginning. Maintaining it for generations is the true achievement, and Tarbela has now served for decades, still standing, still producing, still protecting, still proving that great engineering is never finished. It simply continues evolving. But after more than half a century, one question remains: will Tarbela continue serving future generations, or will engineers need to create an even greater engineering marvel to replace it? The answer may shape the future of an entire nation. More than half a century has passed since construction first began. Generations have come and gone. Technology has changed. Cities have expanded. The population has multiplied. Yet Tarbela Dam still stands, still holding back one of Asia's greatest rivers, still producing electricity, still storing life-giving water, still protecting millions of people. Few engineering projects remain this important for so long around the world. Many great structures eventually become historical monuments, places people visit to remember the past. But Tarbela is different. It isn't a monument, it is a living machine, working every single second, every minute, every hour, every day, without rest. And because the demand for electricity continues to grow, engineers have refused to let Tarbela grow old. Instead, they continue improving it, installing more efficient turbines, upgrading control systems, modernizing power stations, increasing its generating capacity, allowing the same river to produce even more energy than ever before. This is the beauty of great engineering. It doesn't simply survive, it evolves. But perhaps the greatest lesson Tarbela teaches us isn't about concrete, steel, or machinery. It's about human determination. Thousands of engineers, surveyors, scientists, geologists, machine operators, construction workers, and planners work together to achieve something many believed was impossible. They didn't fight against nature, they learned how to work with it. They transformed the unstoppable force of the Indus River into light for homes, water for farms, and hope for millions of people today. When viewed from the sky, Tarbela Dam looks almost like a mountain created by nature, but every meter was designed by human minds. Every tunnel calculated, every slope tested, every stone placed for a reason. It is a reminder that the greatest engineering marvels are not built to impress, they are built to solve problems, to protect lives, and to create a better future. Long after the construction machines fell silent, long after the builders returned home, their masterpiece remains quietly doing its job day after day, year after year, generation after generation. Tarbela Dam proves that true engineering isn't measured only by size, it's measured by the number of lives it changes, and that's why even today it remains one of the greatest engineering marvels ever built. If you enjoyed this documentary, subscribe to RailForge, because every week we uncover the world's greatest engineering wonders, one incredible story at a time. Until next time, stay curious.